So that children, today I am going to start chapter number 7 from the Igcse book, Raise and Wave, chapter number 7. Now that as I have told you children that this chapter is based upon the light, its propagation of light and some characteristics of a light waves. So for the introduction children, listen carefully. Have you ever been to an optician? This is a question for all of you children to get your eyesight checked. Maybe maybe that we have gone sometimes for the normal eye check, and perhaps you are short sighted and have difficulty seeing the details of objects which are quite far away. On the other sides, there are maybe certain defects that long sightedness and find it hard to see things which are near to your face. Sometimes we have seen people reading, they keep their books very close, and sometimes you have seen the people that they keep the reading materials far away for reading. So that is something about the defect. Sometimes we have difficulty in seeing the objects when the objects are very closer, and sometimes we have the difficulty that we can't see the far away objects. Now, one reason you sometimes cannot see clearly is that the lens in your eyes is finding it hard to change shape enough to give you a clear picture. The lens is stretched by tiny muscles to allow you to see distant objects, but allowed to relax. Basically, this is something about the defects in our eyes. This is something about the defects in our eye lens. And to uh, solve this issue or solve this problem, then we have to go to the opticians, and the opticians, they suggest us a better what? Better option in terms of they give us spectacles or even contact lens. Means basically we use artificial lenses to correct our vision's defects. Why we are dealing with this topic, children? That as this is the topic of a light, and light means that light help us to see the objects, and with the help of eyes, we see object in our surroundings with the help of the light. Now, let me go to the next part. That was just a beginning of this chapter. Something that the eyes, importance of eyes to seeing objects. Now, the first topic for this chapter, children, this is reflection of light. Again, children, let me recall that in the previous chapter number 6, we had discussed about sound also reflection of a sound wave. Now, in this chapter is about light, children. So what is this reflection phenomena? Definition is same that we have discussed in the previous chapter. Reflection means the bouncing back of sound or bouncing back of light when it strike on a hard surface, or when light strike on a hard surface. Means here we will talk about a plane mirror, a well polished surface, a plane mirror, a plane, a straight mirror, not a curved mirror, but it's a plane mirror. Now, children, let me come to this diagram. Please look at this figure. On this image, actually on this diagram, what we have given, we have a mirror. We have a mirror, children, a normal mirror that you can see at your home dressing table. We have a mirror, and we have an object. Object means that the from where the light is coming. So from somewhere, that the light is coming, and in this diagram a ray of light is shown. A single ray of light is there, and this ray of light strike where? Anywhere on the mirror, anywhere on the surface of mirror with certain angle. Now children, here in this chapter angles are very important. Try to understand, children. Please pay attention, listen carefully. Here the incident ray, remember this is our incident ray. It strikes on the surface of a mirror. You are listening. So when it strikes on the surface of a mirror, and I have assumed that this is a normal line, an incident ray children, it makes an angle I. You can see here, I. This ray has made certain angle with normal. Angle I, children, this is a very important point. Angle I, any angle of incidence. This is an angle between incident ray, incident ray and normal. Normal means children perpendicular to the plane of the mirror. So this angle, sometimes children, they make mistake. They assume that this is our angle of incidence. Sometimes students use this angle I as angle of incidence, but this is wrong. I is the angle made by the incident ray with the normal. It is not the angle between incident ray and the surface of mirror. So this angle is wrong, children. Remember, many students they forget about it. So you have to be very careful. Angle I is the angle with normal. Then we know when the light strike on the point somewhere on the mirror, it reflect. Suppose this is the point P where the light incident. Then it reflect. It will go back to the same medium. The light is coming from air. The light is going back to the air in the same medium, in the same side. And now, if the light here, this one, this ray, children, the another ray, this is called the reflected ray. After incident at the point P, it reflect back with certain angle. And what is that angle? The name given to that angle is R, small r. And then that is called angle of reflection. Means this angle R is equal to angle of reflection. Reflection. Remember, children, reflection. And this phenomena is called the bouncing back. This is the bouncing back. This is the reflected ray here, children. And this phenomena is called reflection of light. Here we are dealing with, in this chapter, children, most of the diagrams are in terms of ray diagrams, not in terms of wavefront. Wavefronts was the topic or concept in the chapter number 6. So here we will try to draw the diagrams, ray diagrams, in terms of rays, not wavefronts. Now here, one thing that you have to remember in this topic, children. Okay, let me draw one more diagram here. And so this is our, suppose this is a plane mirror. This is a mirror. Okay? The top part is the reflecting surface, and the bottom part, that these small lines, what do you mean by these lines? This portion represent that the back side of the mirror, that is a polished surface, a silver coating, maybe that the painted part. So that back side, these lines are for the shaded portion, means that the painted or the coating in a mirror. And above part, that is the reflecting surface where we see images. And if I take a ray, suppose this is our incident ray, and it strikes, I need to draw a normal also. So I will draw a normal. So this is a normal line, children. This is the normal. And suppose if the angle of incident is 30 degrees, suppose this is 30 degrees, that is angle I. So here angle I is equal to 30 degrees. Bouncing back of this light, so after reflection, this ray of light will go back to the same medium. It will go back to the same medium, the same angle. But children, the direction is very important here. So arrows should be here so that we can find the differentiate. We can differentiate between the incident ray and the reflected ray. So this side, that the ray, this arrow is showing that the light is coming, it strikes somewhere, and then this arrow is showing that after reflection, the light is going in this direction. Here, what about the angle R? This angle R is also equal to 30 degree. This happens in the reflection phenomena that angle I is equal to angle R. And in this case, 30 degree is equal to 30 degree. Whatever the angle of I, that the same angle means when you are drawing a diagram with the help of the projector, compass, whatever you use, you have to take, if the angle I is 30 degree, so the reflected ray should be reflected with the same angle of incidence. Certain activities are there, children, you can discuss it by yourself. Try to do certain experiment at home, children. Maybe something like you can use a laser light, strike on the surface of a mirror with certain angle. You can use a paper, and on the paper that you can draw in the direction of the beam of laser light, draw a line on the paper, and you have to throw, means you have to make the light incident on the glass surface. Sorry, not the glass, but the mirror actually, not the glass, mirror. When it strike on the mirror, it reflect back. You can observe. You have to use you can do at home by taking a laser light, and then you will notice that the angle I is equal to the angle R. A table is there, children, that where you can find if you change angle of incidence. Yes, Jasmine, you are saying something? No. If angle I is 20 degree, angle R is 20 degree. If you increase the angle I 30 degree, reflected angle is 30 degree. Keep changing angle, and then you will find angle R is also changing, and it is the same angle with the angle of incidence. We are giving a certain name to this angle I equal to R, that is law of reflection. If someone asks you what is the law of reflection, the law of reflection is that angle I is equal to angle R. And this rule, they have now, this is very important information, children. This rule is obeyed by all type of waves, all type of waves when they are reflected, but is simplest to measure with light. We have discussed the reflection phenomenon in sound also. Sound wave reflected, that echo is an application of a reflected wave. So reflection is there in sound wave, any type of wave, waves are reflected, but the better to understand the meaning of reflection is easy in case of a light. Let me take one more diagram, children, here to understand reflection topic. This diagram looking a little bit complicated, but let me help you to understand this diagram. Again, we have a plane mirror. We place the plane mirror in a vertical position. You can stand it vertically or horizontally, it doesn't matter. So a plane mirror means you are standing in front of a mirror. Where is the object? You can see that I have this object. This object means like it is a mobile phone. You can take a candle or maybe a book or any object, children. That object is placed in front of the plane mirror. Basically, what is happening here? If you are standing in front of a mirror, that you are an object, you have placed a candle, you have placed a book in front of a mirror, you will find that the image of the object is formed there inside the mirror. There will be an image. So how this image will form, that we are going to discuss here. There are certain steps. Please pay attention. What you have to do whenever you are going to draw, whenever you are trying to find out the image formation, children, remember one basic concept: you need at least two rays of light. Two, minimum two. Maximum you can take any three, four, five, but the minimum two rays are required. So in this diagram, children, let me begin. Consider the top portion of the object at the top point, this one. If I am standing here, that the top portion, and from here, that this one ray, at the red color, this one, the first ray, let me give the name first, and this is the second one, second red light ray. If the first ray strike mirror, where? At this point, what will happen? Here they have not representing angle I. You can draw the normal, and then when this incident ray strike at this point, let me take the point P, then it is reflecting, it's going in this direction, children. It will reflect. This is the reflected ray. Take one more ray of light from the top point and strike anywhere on the mirror, anywhere, anywhere on the mirror, and it will strike. So they have taken the another position. Again, it will reflect it. It is going in this direction, children. Now, where is the image? The reflected ray is going in this direction. The second reflected ray is going in this direction. Something they are going in this direction. They are going away after reflection. Image is always formed when the rays they intersect. When the rays intersect, children, somewhere at certain points. If I need to see the image formation, so what I will do, I will produce the reflected rays, first reflected rays in the back direction, this one, that the dotted line, and the second reflected ray also I will try to extend or produce in the back direction, and they will intersect at here, another point, this point, children. Where the ray intersect, that is the position of image formation. Image will formed here, and you can show the another two rays from the bottom one of the object if you want. You can, otherwise two rays are enough. If you're taking the another two rays from the bottom portions, so this will strike, reflected somewhere, another ray reflected somewhere, produce them back, they will intersect somewhere, and that will give the position of the bottom of the object. Fine, you can trace out that this is a image formed by the plane mirror. In case of plane mirror, same size of image as the object size. When you stand in front of a mirror, even you know that we have a different categories of a mirror. In the museum, sometimes we have seen, we can find multiple images. Sometimes we can find the image bigger than the size of the object, smaller than the size of the object. But in case of plane mirror, if you stand in front of a mirror, you will find the size of the object and the image is same. And one more thing, children, that you have to notice here, where the image is formed. Where the image formed? Actually, image is formed back side of the mirror. Remember here, back side of mirror means it's not about the back side of mirror. It's not about if you someone go to the back side of the mirror, then you will find that the image is here. This is something about image is inside the mirror, but when you stand in front of a mirror, your image is, where is image? Children, where is image? What do you mean by this? The image will form the back side of the mirror. It's not about that the back side of the mirror means it's not about that the image will form at the back side, that after the coating, that the silver coating you find. No. If you move towards the mirror, again you will see that your image is also move forward. If you go back, you will find that your image is also moving away. If you change the position of the object, the image will also change. You can try this at home. This happens. So image is formed at the same distance. Listen, please pay attention. Suppose if the object is at a distance of 30 centimeter, image will form at the same distance of 30 centimeter from the mirror and 60 centimeter from the object. Please make a note of it. That's why I'm saying if you go closer to the mirror, you will find your image is also shifting towards you. If you're going away from the mirror, you will find that your image is also going away from you. But the distance of image from the mirror is same as the distance of object from the mirror. Or in other words, I can say the distance of image and the object will be doubled. Okay, now here one more thing, children, that you have to be remember in this chapter. Then I will end this lesson, children. Virtual and real images. The last topic for today. Virtual and real images. What do you understand by the virtual and real images? In this chapter, this entire chapter is based on these two concepts: virtual images and the real, virtual, real, virtual, and real images, children. So let us find out the difference between what do you mean by a virtual image and what is a real image. It's a very simple concept, but you have to listen carefully. Now, in the previous question, children, when we have seen a reflection phenomena, what kind of image was formed? What kind of image? The image was a virtual image. Why I'm saying it's a virtual image? If someone will say that, no, sir, it's a real image. So how in science and how in physics we can define the meaning of virtual and real image? So let us see now, children. Please read it some this text here. The image formed in a mirror is called a virtual image. Every time image formed in a mirror is a virtual image. It's not real. So in science and physics, let us find out the what do you understand by a virtual image? Because now this is a very important. Because the ray of light do not actually pass through the place where the image is seen. Do not actually pass through the place where the image is seen. Where the image is seen at the back side of the mirror, and these rays actually, in real practice, rays are not going here. Actually, rays are going in these directions. But to form the image, we have produced them in the back direction. Actually, this is not happening. Image is going, the reflection phenomena, this is going away from the mirror. So if the rays are not going in the back direction, but after the extension of the wave in the back directions, then they intersect somewhere. So now again, let me read. The rays of light do not actually pass through the place where the image is seen. This means that it is not possible to display this type of image on the screen. If you place, suppose if you place a paper or a book or a material in front of you and mirror, can you see your image on paper? No. Dear children, this means that it is not possible to display this type of image on a screen. Virtual images cannot be traced, cannot be produced, any picture on a surface, on a screen actually. All images are produced by mirror are virtual and they cannot be projected on screens. Projected on screens again, let me go back to the diagram. If I place, let me do this first. If I place, children, a piece of paper here, so the image here, this one, is cannot be produced on this paper. Cannot be produced. That is the meaning. Virtual images cannot be traced on a paper. on a screen. What about the real images? Actually, not if still you are unable to understand, have patience. In this chapter, we are going to discuss many times about virtual and real images. In real images, what is this? Image produced by some lenses are also virtual, so you will see later, but some are real images also. A real image is one which can be projected on a screen because the rays of light actually pass through the position where the image is formed. In real practice, that the rays in some cases of the lenses, after refraction, they will intersect somewhere, they will pass through that point, and where they will form a real image on the screen. So that is something about a difference. We will find there are many other differences between virtual and real images. I don't want to take your extra time because I want to give you some time for your revision for the coming exams. I want to stop this meeting